This video will help you complete the Using a Travel Time Curve activity. A couple things to do before getting started is to make a copy of the Travel Time Curve activity so you can open it with Cami, and also click to download a Travel Time Curve, which I have opened in Cami and you should do as well to help you complete the activity. So here's the activity page. I'm going to do a split screen so that I can see my activity on one side and my travel time curve on the other side. Now, let's look at this travel time curve together. On the x-axis, we've got the epicenter distance, and you should notice that it says times 10 to the 3 kilometers. So this is 1,000, 2,000, etc. And on the y-axis, we've got our travel time in minutes. So the numbers are minutes, and because each is subdivided into 3 sections, that means that each small gray line is 20-second intervals. I can see that there is a P curve. P waves are primary waves. They travel fastest. They arrive first at a seismograph station. And then there's an S curve. Now this is a wedge in between them, and that will be our S minus P time. So we're going to utilize this wedge to figure out the distance from the epicenter for this activity. So for the first part, it says use your travel time curve to determine the distance to the epicenter given the following S minus P times. So the first time is 2 minutes, 20 seconds. So what you'll do is you're going to mark a line on your graph that is 2 minutes and 20 seconds long. So I'm going to mark my line. I go up to 2 minutes and then this first gray line. So this line is 2 minutes and 20 seconds long. Then I'm going to grab it and I'm going to see where it fits in this wedge. So it's probably around there. So see how it touches both the P curve and the S curve. So that's where it fits within this wedge. And now to figure out the distance, I just come down here and it's right about here. Now, if this is 1,000 and this is 2,000, there are 5 increments here. So each increment in between is 200 kilometers. So I'm at 1,200 kilometers, then 1,400 kilometers. It's kind of in between 14 and 1,600. So I'm going to call this 1,500 kilometers. That's how you'll do the remainder of this table. And then you'll need to describe the relationship between the epicenter distance and the arrival time. For the second part, we need to calculate the S minus P time and then use the travel time curve to determine the distance again. So if we are trying to do S minus P arrival time, we're going to do a little bit of math. I'm going to do mine up here. So I'm going to do my S time first, which is 14 hours, 8 minutes, and 0 seconds. And I'm just going to write this is my S time. I'm going to subtract the P arrival time, which was 14 hours, 5 minutes, and 25 seconds. Now, subtraction of time, you can do it similar just to subtracting normal numbers, but if we need to borrow, so for example, how these zeros, I don't have negative time, I'm going to borrow a minute over here and convert it into seconds. And when I do that, if I borrow a minute, so now this becomes 7, I'll type it for us. So this will now be 7 minutes. And 1 minute is 60 seconds. So I'm going to have 60 seconds now over here. So now I am able to actually do my subtraction. And so I'm going to have 0 hours, because 14 minus 14 is 0. 7 minutes minus 5 minutes is 2 minutes. And then 60 seconds minus 25 seconds is 35 seconds. So my S minus P time is going to be 2 minutes, 35 seconds. And again, what I'll do on my travel time curve is I will take my line and I will make it 2 minutes and 35 seconds. So that's going to be slightly longer than our first curve. And I again just move it and make it fit in between this wedge. So it seems to fit okay right about there, which is 1,600 kilometers. So the distance would be 1,600 kilometers. Now for this third part, it says we're going to use the travel time curve to determine the P travel time. Then we're going to figure out the time of the earthquake. So it's giving me when the P wave arrived, and we know the distance to the epicenter. So for this first one, it says it is 45 kilometers away. So I'm going to take my line and I'm going to put it at 45 kilometers. So here's my distance. And I need to make my line come up to the P wave. So I'm going to grab it and I'm going to extend it upward until it touches. And then I'm going to come over to the y-axis and see where it hits to tell me its travel time. So I'm going to make another line. And it hits the y-axis at about 7 minutes and 30 seconds. So my P travel time is going to be 7 minutes, 30 seconds. So if it arrived at 10 hours, 10 minutes, 10 seconds, and it took 7 minutes and 30 seconds to travel, I need to figure out when it started moving. So I'll do my math up here again. So I'm going to have 10 hours, 10 minutes, 10 seconds, and I'm going to subtract 0 hours because it only took 7 minutes and 30 seconds to move. Okay. Now again, we're going to do some math. It does look like I need to borrow some time again. So I'm going to borrow a minute there. So now this is 9 minutes. And this is going to be 10 seconds plus 60 seconds, so 70 seconds. Okay, so 10 hours minus 0 hours is 10 hours. So the wave started at 10 hours. 9 minus 7 minutes is 2 minutes. And then 70 minus 30 seconds is 40 seconds. So the time that this earthquake began was 10 hours, 2 minutes, and 40 seconds. You'll need to complete the remainder of these tables. They kind of build up your understanding. So start here and keep working through. Then you'll use everything from those first 3 tables to figure out the distance from these 3 seismograph recording stations. Then you can choose one station here to figure out the time of origin of this earthquake. And then on the back or the second page, I've given you the recording stations, and you'll need to use the scale below to draw a circle. So use your shape tool. The radius of the circle will be the epicenter distance. You'll put those circles up here, see where they intersect, and that will be triangulating the source of the earthquake. If you need any more assistance with this activity, please reach out to your teacher.